My dear students, welcome to Chemistry Learning Space. Today I am going to explain the important concept in solid state chemistry, voids. You know very well what is the void and how to form the voids. Generally, the voids are formed from three-dimensional close packing. So, particularly the three-dimensional close packing formed from two-dimensional hexagonal close packing. Two-dimensional hexagonal close packing the AB type. So AB type close packing, two types of voids are observed. So మనకి త్రీ డైమెన్షనల్ క్లోజ్ ప్యాకింగ్లో ఏబి టైప్ క్లోజ్ ప్యాకింగ్లో మనం రెండు రకాల వాయిడ్స్ని మనం అబ్జర్వ్ చేస్తాం. అసలు వాయిడ్ అంటే ఏమిటి? వాట్ ఈస్ ది మీనింగ్ ఆఫ్ వాయిడ్? The empty space between the spheres in three-dimensional close packing is known as void. అంటే స్పియర్స్ మధ్యలో ఉండేటువంటి ఎంటీ స్పేస్ మనం ఏమంటామంటే వాయిడ్ అని అంటారన్నమాట. సో ఈ వాయిడ్కి అదర్ నేమ్ ఏంటంటే దట్ ఈస్ ది హోల్ ఆర్ ఇంటర్స్టిషియల్ సైట్ ఆర్ ఇంటర్సెక్ట్స్. These are the other names. So generally two types of voids are observed in a three-dimensional close packing. The first one is a tetrahedral void. So the tetrahedral void is generally observed in the three-dimensional close packing, particularly AB type close packing. So, what is the definition of tetrahedral void? So, the empty space between the four spheres in close packing is called tetrahedral void. The four spheres మధ్యలో ఉండేటువంటి ఎంటీ స్పేస్ని మనం ఏమంటామంటే టెట్రాహైడ్రల్ వాయిడ్ అని అంటారన్నమాట. సో దిస్ ఈస్ ది రిప్రజెంటేషన్ ఆఫ్ టెట్రాహైడ్రల్ వాయిడ్. దిస్ ఈస్ ది వన్ రిప్రజెంటేషన్ ఆఫ్ టెట్రాహైడ్రల్ వాయిడ్. సో దిస్ ఈస్ ది ఫోర్ స్పియర్స్. Out of four spheres, the three spheres in lower layer, the other sphere is in upper layer. So the four sphere in contact with each other. So some empty space is observed. That empty space is known as a tetrahedral void. So this is the one representation of tetrahedral void. So this is also known as tetrahedral hole or tetrahedral interstitial site. So this is the another representation. So this is the one layer and the dotted line circle is represented the other layer sphere. So the empty space this is the tetrahedral hole. This is the tetrahedral hole or tetrahedral void. These are the two representations of tetrahedral void. What is the other type of void, that is the octahedral void. Octahedral void means the empty space between the 6 spheres in closed packing is called octahedral void. So 6 spheres, empty space, 6 spheres మధ్యలో ఉన్నటువంటి empty space మనం ఏమంటామంటే octahedral void అని అంటారన్నమాట. So the three spheres in one layer and the three other spheres in another layer. So this is the empty space. So the empty space is known as octahedral hole. Octahedral hole. Octahedral hole. This is the one representation. What is the other representation? This is the one layer and this is the another layer. So the 6 spheres in contact with each other, so some empty space is there, that empty space is called octahedral void. So this is the one layer and this is the another layer. Okay. Suppose if now n number of atoms involved in a closed packing, then octahedral void is equal to capital N and tetrahedral void is equal to 2n. So the number of atoms involved in closed packing that is represented as n. Sometimes this is also represented as Z. So if Z is taken, then the formula is changes into Z and tetrahedral void is equal to 2Z. Okay. So the formation of octahedral voids and tetrahedral voids is depends upon the atoms involved in closed packing. So if closed packing involved atoms is n, then the tetrahedral void is equal to 2n and octahedral void is equal to n. Okay. So if any unit cell is given, how to expect the number of voids in that unit cell? So based on this formula, you will easily calculate the number of tetrahedral voids and octahedral voids in a given unit cell. For example, a primitive unit cell is taken. So the primitive unit cell, the Z value equal to 1. So the number of octahedral voids equal to, so the Z value or N value equal to 1. So the tetrahedral voids equal to 2n, that equal to 2. BCC, the Z value equal to 2. So the Z value equal to 2, then octahedral voids equal to 2 and tetrahedral voids equal to 2Z, that equal to 4. FCC, so the Z value equal to 4. So the number of atoms in unit cell, that is known as Z value equal to 4, then automatically octahedral voids equal to 4 and tetrahedral voids equal to 8. ECC means end centered cubic unit cell. The end centered cubic unit cell, the Z value equal to, that is the number of atoms in unit cell equal to 2. Therefore the octahedral void is equal to 2 and the tetrahedral void is equal to 4. So edge centered cubic unit cell. So the edge centered cubic unit cell, the Z value equal to 4, automatically the octahedral voids equal to 4 and tetrahedral voids equal to 8. So HCP, hexagonal close packing. So hexagonal close packing, the Z value equal to 6. So the number of octahedral voids equal to 6 and tetrahedral voids equal to 12. And CCCP nothing but FCC. So the number of octahedral voids equal to 4 and the number of tetrahedral voids equal to 8. So this is the discussion about the how to calculate the tetrahedral voids and octahedral voids in a given unit cell. Okay. Now I am going to explain between the size of the octahedral voids and tetrahedral voids. Between octahedral voids and tetrahedral voids, the octahedral voids are always larger than the tetrahedral voids. Octahedral voids always larger than tetrahedral voids. Octahedral voids larger than tetrahedral voids. Tetrahedral voids. How to explain why the octahedral voids are larger than the tetrahedral voids? A mathematical relationship is there between the octahedral voids and the radius of the octahedral voids and the radius of the spheres, and the radius of the octahedral voids, tetrahedral voids and the radius of the spheres. Okay. Suppose if capital R is the radius of radii of spheres involving close packing, then the radius of octahedral void is the radius of octahedral void, the radius of octahedral void equal to 0.414 into capital R, and the radius of tetrahedral voids equal to 0.225 into capital R. So based on this formula, you will clearly understand the why the octahedral voids are larger than the tetrahedral voids. Because the octahedral void radius equal to 0.414 capital R. Capital R means the radius of the spheres. Tetrahedral voids equal to 0.225 R. So compared to this value is low. Hence the octahedral voids are larger than the tetrahedral void. Okay. So this is our today discussion. Tomorrow I will explain how to locate the voids in a cubic close packing and some problems on voids. Thank you very much.